Well, as usual, every time I put this on the soak test, another problem rears its head. First it was the slight sibilance that I was getting, which is partly resolved, but not completely. It's as good as it can be. Secondly, there was, so many faults, it's hard to remember. But now a third time, I put the machine in my music room for soak testing, and all of a sudden the play wouldn't work. What's happening is the take-up spool just stalls, and I've determined that the torque on the motor, this is the top one here, is gone south just all of a sudden. It was fine before. It was able to completely work and move this hub quite freely, and fast forward, rewind, all the rest of it. And how I know this is now no good is because I can hold the shaft after it's been moving and it will stall. That should not happen. It should be able to start up on its own. So I'm trying to pull it out. Now normally you'd have to take the whole mechanism apart to get to it, but fortunately it's being at the top. One screw I can get to from in here, and the other one I can't, but by gripping it with these pliers, I'll do it left-handed to show you, and I just move that around like that, and it's gradually coming out. I'll finish it because I'm right-handed, and I've got to be careful that it doesn't fall down into it. Getting it back on will be difficult, so I still may have to pull this apart, but hopefully not. There we go. So that's that. Now I've got the motor out, and I'll show you what I mean. Turn it on, and let's go. Fast forward, I guess. Now it feels like plenty of torque there, but hang on. No, then it stopped. Hang on. No, it is stalling, but I'm just wondering whether it's this grub screw that's come loose. I have to determine that. It's running free enough, but there could be just one position on it that's where it stalls. Maybe just the one position. This is a bit sad. It does feel as though it's got quite a bit of torque there, but in there I was able to stall it. Wish I knew how to defeat this motion sensor. It keeps dropping back out. I checked the voltage, and the voltage was about 10 volts, so that should be about right. Well, I do know I was able to stall the motor without any belts on it, so there's got to be something wrong with the motor. Just has to be. So just like that, when it was in here, it was running, I was put my finger there, and I could get it to stop and go like that, and away it would go, spinning. So there was definitely something wrong. try and fault find it. Looks as though I'm going to have to take the motor apart. Oh, hate doing that. Alright, I'll unsolder it and start looking at the motor. I'll get back. Well, I've got it out and now start to disassemble it. It has 4 pinch points around the back edge, so hopefully that means that it should all come through. Good. Yeah, okay, I've got a 9-volt battery on it now, and yeah, I can get it spinning, but moving it around, oops, oh, I did have a dead spot, which is what I was getting when it was in there. Ah, there, just there. So, not moving. Trying to find that dead spot I got before. Oh. There is a couple of points where you can feel something, but it could simply be the crossover of the commutator. Could be just some sort of vacillation between poles on the commutator. But the shaft isn't moving. Well, that's sort of good in a way because, well, it means I didn't pull it apart for nothing. But I think it does mean I have to pull it apart. Oh, dear me. Alright, here we go. Now, I've done a couple of motors in the 1000 ZXL, so I've got a little bit of practice doing this. There's 4 pinch points around here, which I'm trying to straighten up a little bit. Just this is hard work. Right, here we go. I'm going to have to straighten it all after I've finished. Right. Oh, it's a motor within a motor. It's in a cage. So here's the real motor. Okay. Feels free enough, that's the thing. Unless one of the prongs on the commutator is broken, that's possible. Now once again we got these little things pressed on the side to hold it. Oh, this works quite well. I'm going to have to get some Allen keys to undo that shaft pulley. I better take this off. Allen keys, where are you? Well, I couldn't find a Allen key small enough. The smallest I had was 1.5mm, and I suspect, well, it is smaller than that. Anyway, I went through my Imperial stuff and found a 3/64 that actually fits close enough. I mean, 3/64, what a stupid system of measurement. Right. Snap. And off it comes. Right, now let's see if we can get this out somehow. How do we do that? Right, okay, a bit of leakage here. Yep, it's coming. Right, so let's push it out. Yep. It's got a bit of spring to it because of the magnets. Now this will be the tricky bit to make sure we don't lose anything. There's a little tiny washer down the bottom there. You can just see it, a little white one. Alright. I'll just leave him there. He's safe. Now, this is where we find out if anything was wrong. Yeah, let's try and zoom in a bit. There's a little inductor in series with the red wire. That's that little coil there. Okay, that's fair enough. And there's a capacitor. Oh, there's a capacitor across the motor after the coil. So it's a LC network across the up in front of the motor. Now this is where we pull it away, and it'll be interesting. Okay. I hate to say it, but so far it looks alright. Now these are the brushes. I mean, they could be just dirty. Huh. There is a bit of muck in here. Well, actually, that's a point, although it's fairly well covered, but oh no, I was sorry, I was thinking of something else. Forget what I was just thinking. However, there is a little small amount of black dust in here that may have built up and caused trouble somewhere. The other thing is that this capacitor, I need to check to make sure that it's, well, something. One of the other motors I repaired, it was weak as Larry. As soon as I put the capacitor back across it, it was all gung-ho. So having that little capacitor across the DC motor genuinely helps it along. Appears mostly okay, but the only thing that could be a worry is the commutator might be a bit dirty. It does look a bit dirty, but not too outlandish. What I'll do is I'll get some alcohol and a cotton bud. and give it a bit of a clean and see what comes off. First off is the commutator. There's a bit of black stuff coming off. Oh, there's actually some adjustments here. How weird is that? I wonder what they do. Oh. Oh, they're contacts. Ah, dearie me. Yeah, there's two contacts either side with a brass weight on it to give it mass, I guess, and a little contact. Why would that be there? It could be like a flywheel arrangement, when it's spinning and they don't make contact. I don't know enough about motors, I'm afraid, to figure out what that is actually doing, but yeah, I reckon that's what it's doing. It's like a it's like a speed control almost. Anyway, I'm not sure. As I say, don't know enough about motors. I'd like to be able to clean those contacts, but to get in there, certainly can't use a cotton bud. I think I would have to use a little bit of paper soaked in alcohol. Whoever thought up these things and worked it all out. Anyway, I'll carry on, and another cotton bud, and clean the brushes. Let's see how we go here. While I'm down there, I'll clean the top of the shaft end. There's a little bit of muck came off, but I mean, quite often in motors they're carbon blocks anyway, so you expect a little bit of blackness. Got to measure that capacitor. It looks like, what would it be, 100 puff or something? What is it? 203. Well, that's 20 nanofarad. Whoa, that's quite a bit more than I thought. Alright, well, let's measure it and find out. Right, press test. Oh, look at that, 21 nanofarad. Put that over there. Alright, so the capacitor is fine. Well, I think we have to put it back together now. No, I'm going to try and clean those centrifugal contacts with a just a little bit of paper soaked in alcohol. I found a little bit of thick paper, which should do the job. Just go in and out a couple of times. Oh, there's a bit of blackness there. Ooh. Yeah, I might have done the same one again. I'll do the other one now. Oh, there's a bit of blackness come out of that, so I think that that should now be better. Whether it will be sufficient, I don't know. Do not know. Okay, we'll put it back in now, and I'll put some oil in there. A drop of oil down this end here, which down in there, and then another drop of oil in there with my trusty syringe. It was running free enough before, so I'm just hoping that cleaning those two centrifugal contacts and the commutator and the brushes will be enough. So, yeah. Well, the springs, which is basically just rubber for the brushes, they seem to be mostly, yeah, pretty good, about what you'd expect. So, yeah, I'll just have to get some really fine grit paper and see what I can do about cleaning up the brushes and commutator better than just simply alcohol. With a bit of luck, that might cure it. If not, it just means a new motor, which is a bit of a shame because it's all sort of there and nothing really super wrong. Just from what I can gather, a dirty commutator and brushes. It will be a challenge to clean them, that's for sure. Alright, I guess that's where we leave it now until I can get some really fine grit sandpaper. My 60 or 80 that I have is obviously not suitable for this purpose, so I'll get back to you as soon as I get some. Righto, bye. Okay, I've got some wet and dry paper. It's a 800 grit. Got a few various grits, but I don't want to be too severe with it, so 800 feels about right. So we'll just cut off a little strip. Now, this is where it gets a little bit difficult. I mean, one idea is to stick this in the end of a drill and rotate it, but may not need that much. So what I'm doing is, it's still a bit too wide, alright. Basically a strip of it that I'm going to rotate around the armature. The idea of having it wrapped around is so that it provides a nice even pressure around it we don't want to be creating flat spots. Okay, so I've wrapped it around like that. Yeah. Yeah. It's hard to keep a grip on it. I think that's doing a nice job of it, actually. Copper's a fairly soft metal, so it should polish up quite nicely. Ooh. I'll get some, have a closer look. That looks really good. That looks really good. It's there was a little section near one of the gaps where it looked a bit dark. Just sort of like for a couple of millimeters or less on one side of one of the gaps, but that seems to have gone away and it's all nice and clean copper now. So, right, just a light brush around. Bit of clean with alcohol. Well, that looks terrific. It polished up really nicely. Yeah, the 800 grit was more than rough enough. Probably could have used 1000 or 1500 grit actually, but it wasn't available there for sale, so 800 was the finest I could get. But that's all right. It seems to work without too much. It's good. Good. Okay, the next thing is the brushes. Now, with these, the thing is that I'm not sure of the diameter of the arc on the brush contact. I'm not sure if it's the same arc as what goes around the armature, or whether it's slightly sharper angle or less radius in the contact point, which means that as it goes around, it's actually touching on 2 points for each brush rather than a single contact, but I'm not sure. And the only way for me to find out is to see if I can do a few measurements. This may or may not be a bother, but we'll just see what happens. Oh, I'm going to approach this in 2 ways. One is by using little drills. I hope to see if I can match it to the contour inside the brushes and see what that diameter is compared to the diameter of the armature. And let's measure the armature just for a starting point. .9. 4.92, 4.89, yeah, let's say 4.9. So diameter of 4.9 millimeters. Now there's a set of drills, and we'll see if we can match one up. This is where I need to use my little microscopy thingy. Let's start with, well, 4.5. That's probably a good start. Yeah. Trouble with technicians, we need bloody 3 hands to do anything. Need to hold this, hold that, and hold this all at the same time. But are useless. Alright, I'll see what I can do. How am I going to do this? This is actually a smaller diameter, so let's go with 5, see what happens. I really thought it'd be smaller, but no, it looks to be the same size as the armature. Seems to even be a little bit bigger than that. Let's go with the next one. What's that? So hard to see without glasses. 5.5. All right, let's try 5.5. Oh, God. Hard to get a good grip on it, but oh. How can I do this? Let's try. Okay, sort of working, I think. So I'm using the 5mm drill bit, some 800 grit paper, and just going up and down the inside of the brush in the middle so that it sort of keeps its curve. Let's see how that looks. Yeah, better. Bit more. To get in there, and in fact I'll have a look now. Oh yes, there it is. So yeah, it's on the pulley that's in behind there, and there's the rubber band, and I'll just stick it on this one. I'll stick it in, which might try now. Oops. Right. Try again. I don't know why I had so much trouble putting it on. Yeah, that's better. Yeah. So that belt's on now. So all I have to do is screw it in. And if I remember right, these are the screws. One is really hard. I'll have great amount of difficulty putting that in. In fact, I'm tempted to drill a hole here. That's not a bad idea, actually. Anyway, we'll see how we go. I'll do this one first. The trick is that will I lose any? Alright, there's that one. Now this is where it gets terrific. I reckon I'll just drill a hole, you know. It's not going to matter. The only trouble is the swarf. That's going to be the matter. Yes, the swarf. Alright, yes, alright. I think I might have to do the reverse of what I did. I'm going to drill a hole. It'll make life so much simpler. But to do that, I have to stop the swarf. Oh God, it needs to be 6mm. Well, I've put the motor back in, and it doesn't have a huge amount of torque, but it is working and it's not stalling like it was, so that's just how it is. What I had to do to get it in there, I had to drill a hole in here so that I could push the screw through. It was just too difficult any other way, but it's alright. Little hole there won't hurt it. It's only plastic, and there's good strength all around it, and certainly makes it easier for getting that motor in and out now. Just real easy. So if it ever has to be, yes, it doesn't take much to stall it, but it's not like it was before. It actually is spinning and doing its job. Actually, what voltage is on it? I mean, it's 12 volts full pelt, but what is it when it's in play mode? 7.9 volts. Yeah, so it's not a huge voltage on it for torque, but that's the way it is. I can't see how the motor could be any stronger without putting in a different type. So we're back in business. Alright, I'll go and soak test it now for the 4th time, and hopefully nothing rears its ugly head again. Righto.